All right, I changed my mind. We're going to do the last two problems on 10.4 because they're not as straightforward as what I thought. So we have an airplane. It's a jumbo jet, and it maintains a constant airspeed of 400 miles per hour due north. Okay, so let's draw a picture. We have this. Here's the airport, and my little airplane is going 400 miles. I'm trying to make so you can see that. Due north. So that's my vector. Okay. The jet stream is 100 miles per hour in a northeast direction. So remember that this is 400, which it would have been really nice if I'd gone up to here. So it would be like 1, 2, 3, 4, but I didn't. So my jet stream is going to be 100 miles per hour in a northeasterly direction. So first of all, I want to express the velocity, v sub a, of the jet relative to the air. Okay, so I have, hang on, I'm looking for a pen that works. All right, so I've got the velocity of the jet, so the velocity of the airplane, okay, relative to the air. Okay, and you're like, wait a minute, what does that mean? Well, hang on a second, I'll tell you. All right, so we know he's going 400 miles an hour due north. We know the jet stream is due north, 100 miles per hour northeast. Okay, so the velocity of my vector, okay, is going to be, the velocity of my airplane is going to be, it didn't move left or right. So there's no I component. It only has a positive J component, and that's 400 J. Okay, so no I's because it didn't go left, right, but it did go up 400 miles per hour. My jet stream is going to need a little bit of attention. So this is the miles per hour up where the airplane is flying, and that wind is pushing at 45 miles per hour. So I do know the velocity, but I'm going to have to turn around and find, so we're going to do the velocity of the wind. Okay, so for the velocity of the wind, we are going to use the fact that we know it's 100 miles per hour, but we also know that this, where's my green pen? This angle right here, because it's northeast, that means it's 45 degrees. So it's 45 degrees from north, 45 degrees from east. So it's 45 degrees. So I do know that I can represent this as cosine of 45 on I plus sine of 45 on J. Okay, and so now do I know what those angles are? Yes, I do, because I want to be in rectangular form. This is polar form. So I'm going to go ahead and convert. So I've got 100 times root 2 over 2 on I plus root 2 over 2 on J, which gives me 100 divided by 2 is 50. So 50 root 2 on I plus 50 root 2 on J. So my jet stream is going to be represented by this vector right there. So what I've got then is 50 root 2 on I plus 50 root 2 on J. So this is the airplane going this way on his merry way, but then the jet stream is going to affect him. So I want to know what his actual speed is and what his actual orientation is. So I'm going to add these two vectors together. So the velocity of the airplane plus the velocity of the wind stream will tell us what is going on with our airplane. Hang on, I have to sneeze. All right, sorry. All right, so this is 400J. So remember there's 0 I's plus 400J plus the velocity of my jet stream, or the vector for my jet stream is 500 root 2 on I just said 550 root 2 on J. So I'm just going to add those together. So my I components just stay at 50 root 2 on I. And my J components become 400 plus 50 root 2 on J. So that's the vector when I add these two things together. All right, so I've got a red vector and I got a green vector, and when I add these together, I get that vector. So bottom line is that this wind is pushing the airplane that direction. So what I would like to know is, now that I know what his actual movement is, I would like to know his angle. I want to know his trajectory. So his trajectory is just going to be the magnitude of this new vector. Okay, so not the magnitude, the angle measure of that vector. So what I get is, and this is going to be the velocity on the ground, by the way. Okay, so add those two. So the actual airspeed, the jet stream or the wind, add those together and we get what the velocity is, or the vector is on the ground. I keep saying velocity. We get the vector on the ground that the airplane is following. Now I want to know what his actual ground airspeed is. So his speed is going to be the magnitude. Just like the magnitude of this was originally 400 miles per hour. So I tracked it at a length of 400. Okay. But this one is on a diagonal, so we got a little bit of work to do. So the magnitude of my vector from the ground is going to be the square of my horizontal component plus the square of my vertical component, and then take a square root. So looking at that, I have the square root of 50 root 2 squared, okay, plus 400 plus 50 root 2, close that, and we get squared. And hit that, and we get about 476 miles an hour. So that is what my airplane is doing. So that is 476 miles per hour. All right, the next one I'm going to set up, and I'm actually going to do it two different ways. So I'm going to do it one different way, but I want to draw you a picture of the thing first. So I'm just looking for random paper that I can draw on. Give me a second. Okay, so I've got this, and my second problem that we're going to work through is going to be, I have an object hanging from two cables. Okay, the object weighs 2,100 pounds, and we need to recognize that this is actually the x-axis, this direction. So I do know that this angle measure is 25 degrees, which means this angle right here, because it's a transversal, is 25 degrees. So we'll just write that down. Actually, we'll write it in pencil so I can erase so you can see it later. All right, so that is 25 degrees. Okay, and then this angle right here is 40 degrees, which means this angle is 40 degrees. So again, the transversal, if this and this are parallel, then the alternate interior angles have the same measure. So if this and this are parallel, then the alternate interior angles have the same measure. So what I would like to find is the forces of the two vectors. Okay, meaning I need to know what force this is exerting and what force this is exerting in order for this to be stationary. So I'm going to set up the basics of it, and then I'm going to write everything else on a different sheet of paper because this one gets a little bit long. All right, so first of all, let's do force 1. So we've got the first force, which I'm going to write in blue, is going to be found by the magnitude, which is the actual force. Okay, this is what we're trying to find, times the cosine of those angle measures. Now, if I come back and look at from here to here, because I'm measuring from the positive x-axis, 180 minus 25 gives me 155. Okay, so this will be times the cosine of 155 on I plus the sine of 155 on j. Okay, the second one is we're going to grab this one. Okay, So this will be force 2, and I'm going to be looking for his magnitude, okay, because I know the angle measure. I just need to know what the magnitude is. So I've got the cosine of 40 degrees on I plus the sine of 40 degrees on J. And then my final one is actually the fact that I've got a vertical thing. This is gravity, okay, that is holding my 2,100 pounds. So if I am measuring that from the positive axis, so let's drop this down a little bit, okay, know that my weight is at the bottom, and so I'm going to have to come around to 270 degrees, okay? So force 3 is going to be, and I know the force, okay, because the force is the weight, so it's 2,100 times the cosine of 270 on I plus the sine of 270 on J, which means there's no variables here. I know what the cosine of 270 is. It is 0. So I have 0I minus 1 on J. Good heavens. Okay, because the sine of 270 is -1. So when I distribute that, that weight or that force, that's going to become a negative 2,100 on J. Okay, so this is our setup. Now, what we learn is that if I add these three forces together, force 1, force 2, force 3, if I add them together and this is stable, it's not moving, then it's got to add up to 0. It must add up to 0. Okay, so to make my life a little bit easier, I am going to change my forces to just x's and y's. It's going to make life a whole lot easier when we're solving if I'm not using magnitudes and forces and this kind of mess. So I'm just going to say that the magnitude of force 1, I'm going to write as an x, and the magnitude of force 2, I'm going to write as a y. And theoretically, I should probably use like alpha and beta or something like that, because this is an x component and this is a y component because it's horizontal and vertical. But it'll just be clearer to you in a second if I use x's and y's. So if I add up these three vectors, or these three vectors, I'm going to get an answer of 0. So that's where we're going to come over to this piece of paper. I got force 1 plus force 2. Force 1 plus force 2 plus force 3 must equal 0. And I know the entire piece of information for force 3. It's just negative 2,100 J. So I'm going to replace this with an X. I'm going to replace this with a Y. So what I have first is F1 is going to be X times the cosine of 155 on I plus X times the sine of 155 on J. Okay, so what did I do? I took X and I distributed. Okay, so now we're going to do the same thing with Y. So I have plus, this is now force 2. So I've got Y times the cosine of 40 on I plus Y times the sine of 40 on J. And once again, I've run out of room. So that is force 2. So I took Y because I'm just using substitution. Forgot my equal sign. Okay, so Y times cosine, Y times sine. And then I need to add that third vector, which is going to be minus 2,100 on J. And all that needs to equal 0. So this is force 1. Force 1 was blue. Okay, here's force 2, which was red. And here is force 3, which was green, and it's minus 2,100 J. And all those added together must be 0 because we've reached a state of equilibrium. There's no movement. All right, so what are we going to do? I am going to do what we've done before, and I'm going to add up my I components, and I'm going to add up my J components, and we're going to go from there. So what we have first is, and we're just going to use a different color pen, so I'm just going to go back to blue. if I add up my i's, I'm going to get x cosine 155 plus y cosine 40 on I. Okay, so I've got x cosine 155 plus y cosine 40 on I. Okay, so I've added my i's together. Now I'm going to add my j's together. So plus x sine 155 plus y sine 40 minus 2100 all on j will equal 0. Okay, so these two things added together must be 0, so we're going to set each of them equal to 0. We're going to set each of them equal to 0, and what that's going to do is it's going to create a system of equations. So I'm going to take my I component, and I'm going to say, well, u can be 0. And I'm going to take my j component, and I'm going to go ahead and add that 2100 over. So pretend like none of this stuff is here. I'm going to add 2100 to both sides. Okay, so that gives me x sine 155 plus y sine 40 will equal 2100. All right, so I had some hiccups right there, sorry. I wrote it at the top of another page just so it would be a little bit clearer as I write it through. So, and I made a mistake right there already. So what we have is a system of equations. I'm going to go ahead and convert this stuff into decimal approximations now, rounding everything to 4 decimal places. So I need to know what the cosine of 155 is, and I need to know what the cosine of 40 is. And so I've got these 2 decimal approximations for my top row. So my top row is going to become x times the cosine of 155 is a negative, actually I'm going to do this different. I've got a negative 9063 times x. Instead of leading with x, I put it at the end. And then the cosine of 40 is 7660. So I have 7660y will equal 0. And then my second row, I need the sine of 155, and I need the sine of 40. And so this term will become 4226. So I've got 4226x plus, and then y times the sine of 40 will be 6428. So 6428y will equal 2100. All right, so what I'm going to do from here is use substitution. So just fair warning, if you use the matrix feature on your calculator, there'll be a rounding error. And so looking at this for substitution, I'm going to grab my top row and I'm going to solve for y. So my top row says negative 9063x plus 7660y will equal 0. So I'm going to add this negative term to both sides. So 7660y will equal a positive 9063x. And then I'm going to divide both sides by 0.7660. So I get y equals 9063 divided by 7660 gives me 1.1832. So 11832x. So now I know what y is. So I'm going to back substitute up into here, and I'm going to flop out y for this value here. So I've got 0.4226x plus 0.6428, but instead of y, I am putting 1.1832 times x equals 2100. Okay, so I've got this many x's plus this many x's is how many x's? So I've got 0.4226 plus 0.6428 times 1.1832 gives me a total of 11832. Okay, so 11832 what? 118.32 x will equal 2100. So divide both sides by 118.32. So 2100 divided by 118.32 gives me 1774.8. 1774.8. So now that I know what x is, I can go back up here and I can find out what y is. So y is going to be 1.1832 times 1774.8. So my y is going to be 1774.8 times 118.32, and I get 2100 is what I get. 2100 is what y is. So back this mess up. Where is my pretty picture where I started writing all this? Give me a second. I've lost my pretty picture. Where did I put my pretty picture? Okay, there it is. All right, so I know that the force or the magnitude of force 1 is x. So the magnitude of force 1, that's the wrong page, sorry. The magnitude of force x is 1774.8. So that is how many foot-pounds we're doing, or joules or something. And then my y, what is my y? My y is 2100. So now I know those magnitudes, and it just made life a little bit easier to do the substitution the way I did with x's and y's. That way we're not cluttered with all the vertical lines and stuff. So that officially concludes section 10.4.